All right, this is your overview video for week 3. I'm going to go over all of the content modules here and what you'll be looking at. And there will be a separate video, by the way, talking about the assignment from last week and with the feedback on that, and also another video on the assignment for this week too. But this is kind of your overview, so let me jump right to it. You go to your Blackboard course documents page here, and it has week 3. Start here for week 3. Now, you'll see this video modules week 3. I will be posting hopefully today, Monday. I'm recording this. June 1st. There will be a video below this that will talk about your assignment from last week and give you a little feedback on that, general feedback on, just to share with you as you move forward with your future case study assignments. So you go to video modules week 3. The first one, there's 4 modules here of content. First one right up top, we go right to the case study for this week, which will be not in Virginia, actually. It'll be a tornado that happened in the southwestern part of Michigan back on March 6th, and it's notable because there were no warnings issued for it. There were 4 fatalities, and in fact, the convective risk outlooks from the Storm Prediction Center were kind of minimal. They were marginal at best when the event unfolded, and this was an isolated storm that just happened. It was a supercell, and it ended up with the 4 fatalities, and one of those occurred before a warning was even issued. There were no tornado watches or severe thunderstorm watches either during this leading up to this event. So that's why I think it's important, because we're talking about the communications, how it failed literally in terms of getting the word out quickly enough to about the storm, and it's because the storm itself happened so quickly and it was isolated. And that's the way weather is, and so it just reveals the complexities of dealing with severe weather and trying to communicate that risk. So I thought it was very useful and a perfect case study to share for this week, which is focused on severe storms. Okay, so the week overall, we're talking about severe thunderstorms, tornadoes, flash flooding, those kind of weather events, and how we communicate the risk for those. And I thought this March 6th tornado event up in Southwest Michigan was a perfect case study for this. So you go to the module 1, there are 2 folders here. You open each one separately. The severe storms content folder, which basically contains videos talking about background information about the convective outlooks, conditional intensity outlooks issued by the Storm Prediction Center, which is something that is mentioned in some of the videos that I'm talking about in the case study. So some background information about hazard information. What are the difference between watches and warnings for tornadoes and severe thunderstorms and flash flooding and such? So talk about all of the hazards here in these short clips. And then at the bottom, I have a video from a couple years ago, actually. It's a 4-minute video, but I talk about the real risk from tornadoes, which is EF0s and EF1s are the smallest tornadoes, and by the Fujita scale, and then the stronger ones are EF2s and stronger. But I talk about the real risk from tornadoes. Most of the tornadoes we see are the weak ones, but the fatalities generally occur mainly from the more intense tornadoes. So this goes back to how NSSL is trying to define the intensity of tornadoes, not just if they're going to happen, but how intense they could be with this new conditional intensity outlook. And this short overview video, which is very short, less than 2 minutes, really explains it nice and succinctly. Okay, so that's the first content folder to give you within this first module, to give you background severe weather information that you will look at when you're watching the case study, which is here. So make sure you open this folder, the case study for the March 6th deadly Michigan tornadoes. Okay, and misspelled Michigan here. I will fix that. And there are 2 primary videos here right up top, and they're the March 6th tornadoes PowerPoint 1 and PowerPoint 2. And this gives you a lot of background information. And then the second one, I talk about a look at the piece by Alan Gerard that was written in his Substack feed the day or 2 after this tornado happened in Michigan. And he talks about how things didn't work in terms of the warning systems and such, and getting the word out, and how there wasn't a reception of warning information in a timely enough manner, and why and what things could be done to fix that. So this is an overview of that article I share with you, and it's 25 minutes long, but I go through the whole article because it gets kind of in the weeds a little bit, but I think it's really, really important information for this case study. So please watch that. And then here's the link to the actual article from his Substack feed. And then mentioned in one of the PowerPoints is some commentary from Dr. Sean Ernst, who is a professor and a researcher in meteorology, and he is referred to in the Alan Gerard piece, but he talks about some of the failures that happened from the communication standpoint during this March 6th tornado event. So it's important to just kind of understand where he's coming from, and some of his commentary is really useful. And I think you'll get some insights out of that. And then here's a link. This is after these two PowerPoints. Here's a more kind of general things about the storm. This is a link from a YouTube page I found for a meteorologist who did it's called the Convective Chronicles page. He talks about severe storms and such. And I want you to watch just the first 5 minutes of it. So the direct link to his YouTube video here is here. And then watch the first 5 minutes, because what he does is just gives a breakdown of what happened that day in terms of what was the meteorology of what happened that day with that outbreak, that tornado. It wasn't really an outbreak, an isolated, intense tornado that happened over Southwest Michigan. And then here's some news story information as well that I shared. So again, all of this is in the content folder for the case study. So make sure Module 1, here's the background folder, here's your case study folder. Make sure and open that. And then finally in Module 1, I have this little clip I want you to watch from what is called a Weather Brains podcast. And this is a podcast hosted by James Spahn, who is a meteorologist, broadcast meteorologist down in Birmingham, Alabama. And he has been hosting this for many years. This is from 2019, so it's 6-7 years ago. It still plays really well. And the reason I want you to watch this older podcast is because there's a 15-minute segment in here that talks about the problems and the issues that forecasters have to face when making decisions about issuing convective outlooks and warnings and these sort of things. There's a lot of thought that has to go into all of this before warnings and even convective outlooks are issued, and all of the issues that kind of go through the minds of the forecasters that really are things we don't think about in the general public. Okay, and so I think this is really important important information you'll glean some good insights from. But you don't need to watch this. The podcast, the whole thing. Podcast is 2 hours long. Go forward to about the 35-minute and 20-second point. So skip to that and watch about 15 minutes. And it's a segment where Kim Klockow, who is a former researcher with NSSL and a leader in the field of social science and meteorology, she discusses these aspects, rather, of how meteorologists have to make decisions that are really tough to make, okay? And how they go to the communications of severe weather information and how all of these issues kind of come into play. So it really kind of wraps everything together that we've been talking about so far in this class. So that's it for Module 1. There's a lot of stuff there, but the main thing is a case study. I want you to realize there it is for this week. And then for week 3, Module 2 is a presentation from another NSSL researcher. This is from Mackenzie Krochak, who shared with us in week 1 the PowerPoint slides. I showed you the Communications 101 slides. Mackenzie actually does a full presentation for us here, and she shared it with me. And it's a video of her presenting for about 30 minutes about how important it is to use probabilities in communicating weather risk. Okay, and we talk about that. We've talked about it a little bit before. It's really important moving forward because I'll be discussing it quite a bit. The probabilities, even though they're often misunderstood, are a really essential tool to communicate risk because they define the uncertainty of risk. And we've already talked about that. So defining the uncertainty of risk is important because you can describe all the possible outcomes, which I discuss about in your assignments as well. So that's really important. So this is key information. And I do another video on uncertainty and risk communications. It's my own PowerPoint on this, where I talk about how important it is to convey uncertainty in risk communications. And again, it all goes back to how if you don't communicate all possible outcomes and things don't happen as you expect in a forecast, then people lose trust. And, there has to be transparency in sending out the information and telling about how you feel in terms of a certainty about a certain outcome and what those could be. So this is again all kind of covered here in this module. Then finally at the bottom there's a slide from the National Weather Service down in Birmingham issued this about using probabilities and risk communications. A really good you know good statement that kind of explains things well. Below that, I define just share some information about defining all the warnings, how the National Weather Service differentiates severe thunderstorm watches versus warnings versus tornado watches and warnings, that sort of thing. And then a SkyWarn video. SkyWarn is an important program that is done by the National Weather Service, where volunteers, such as any of us, can take a short course, and then they teach us how to identify severe weather as it's happening. And by doing that, as a SkyWarn volunteer, I can contact and submit to the Weather Service when there's severe weather happening that I'm seeing my information, what I'm seeing. And it provides ground truth to severe weather situations. They may see severe thunderstorms on radar, the Weather Service and such, but when they see ground truth that, hey, there's eyes on the ground that are seeing this happening, and so we can confirm there's a tornado, for example, or confirm there's wind damage, or confirm there's flash flooding. So the SkyWarn program basically is a kind of a way to crowdsource weather information, but in a very formal way, a structured way where people trained by the National Weather Service are volunteers. They don't work for the Weather Service, but as a SkyWarn volunteer, you communicate weather as it's happening on the ground. And this all goes to the social sciences because we are all in the communications business. The more we communicate actual ground truth, the Weather Service can provide more timely weather alerts and warnings and give updates to people to keep them safe. And so the communications all kind of cycles around, as I've talked about often. So far in this class, I've talked about it quite a bit. Okay, so that's Module 2. Module 3 is talking about a warning system that's called the Warn On Forecast system. And this is important because this is a new way that NSSL is trying to enhance communications of severe weather information. In other words, if there's going to be a tornado happening in the afternoon, maybe, oftentimes, or most of the time, you don't know if it's happening until you see a radar signature on radar. By you, I mean by the Weather Service or meteorologists see that radar signature. Well, the Warn On Forecast system basically takes it one step further and tries to give more advanced warnings to people about tornadoes happening by using advanced computer, very high definition computer modeling and high resolution modeling to predict where tornadoes will happen. And not just where the chance will be, but where the tornadoes will likely happen, and giving areas where they could track, and doing so maybe 2 or 3 hours in advance of when the tornado could occur. So this is a really groundbreaking type research that's being done by NSSL. It's called the Warn On Forecast System. The acronym is pronounced WAFS. And Patrick Burke is the lead researcher there, who I interviewed for this class. He doesn't actually physically record. He's not actually physically here in a recording on the video, but he shared with me all of the insights that we're talking about in this class, and he shared all of these slides with me, which I go over in this PowerPoint, that talk about the WAF system, the Warn On Forecast system, how it's used. It's still only used in certain situations. It's triggered by the severity of event that might happen. In other words, if there's a convective outlook that is a moderate risk for a certain area on a certain day and time, NSSL may see that the WAF system is triggered to kick in for that event. And the reason why it's not used in a more widespread fashion right now is because it takes a lot of computing hours and time to produce these forecasts, and to even kind of spin up the forecast for a certain event, it takes a little preparation too. So it can't be done just instantaneously. There has to be a little forward look that, hey, this would be a good day to use the Warn On Forecast system in these certain situations. I go back to the forecast, the March 6th tornado case study. This would have been a perfect use that day for that. To my knowledge, it was not used during that forecast situation because the convective outlook just didn't show overall that there would be that risk that unfortunately did happen. All right, so this is really a lot of content here, and again, it's something I talk about because it really points to the communications of severe weather information needs to get out in a timely manner to be effective. Okay, so people need to receive the information, then they need to comprehend it and understand what's going to happen. But the content of that information, remember, there's that we have the sender, the communication, the receivers. The communications of the information has to be done in a timely manner. And remember, when people comprehend forecast information, one of the key kind of breakdowns in the comprehension is how soon do I need to react, or what does it really mean, in terms of how should I stay safe. So this tries to answer the time to warning situation. In other words, it gives people more advance notice. The more time you have to react to severe weather, the better prepared you will be. Okay, so this is all again in this folder. I also refer to a case study. Here's a WAF's case study page, which has overviews of various case studies, and then this was used for an extreme flooding event in eastern North Carolina back in 2025. So the meteorologists in North Carolina knew there would be some flooding happening with a particular weather event in this event, which was June 15, 2025. And so the WAFS was actually triggered for this event. So the Warn-On forecast modeling system was triggered, so it was used here, and this video talks about the use of it. And then the future of WAFS that's just talked about below, which talks about how cloud computing now is being more and more used by NOAA and the National Weather Service, and that allows a better integration of all of their computing resources. It requires less time, faster computing, and more sharing of information because if there's a severe weather event expected in, say, Colorado, and the forecasters at NSSL aren't aware of that necessarily so because there's other things happening nationwide. Well, by the cloud computing, there's more of an integrated communication between all of the meteorologists nationally. So that's really important trend that we're talking about in terms of improving the use of the Warn-On forecast system, which right now is only used in a limited way. Finally, in Module 4, I talk about impact-based warnings, and the impact-based warnings are in two folders here. We have impact-based warnings, and in this folder, everything about radar folder. Just gives you lots of information about radar and NEXRAD and stuff, so stuff I'd like you to kind of review and understand. But impact-based warnings are basically, they've been around for a few years, but they're basically weather warnings for primarily severe weather situations where we have convective risks like severe thunderstorms, tornadoes, flash flooding, high winds, those sort of things. The impact-based warning is basically a forecasting shift paradigm from what will the weather be to what will the weather do. In other words, instead of saying the weather is going to be doing this, the weather is going to be stormy, the impact-based warning will say the weather will be stormy, there will be considerable risk of tree damage, and here's ways you can stay safe. So it's adding content to explain what the warning means as an example. So these are called impact-based warnings. They talk about the impact of certain storm situations. And I do these videos explaining these impact-based warnings, overviews from a webinar. The Weather Service in Wakefield did a great webinar back in 2021 on these. So I kind of go over that content because they've been improved a little bit and modified, but the basics are still happening here. They may have added a tweak or two to their impact-based warnings, but this first 30 minutes of this webinar covers all of the basics that I talk about in these slides here and this presentation. Basically talks about what is the impact-based warning, when is it used, why is it important. So when there's a severe thunderstorm warning, you'll see certain additional language added to it that tells you how bad it's going to be, what it's going to do, what impacts it'll have. That's the whole new paradigm shift with the National Weather Service, which we talk about more next week as well. So again, and it's used globally, and I show examples how it's not just a U.S. National Weather Service thing. There's a video from New Zealand where a presentation how they saw that impact-based warnings were very useful. But I go down here with another video talking about this was a seminar I attended online from a New Zealand forecaster and researcher who says impact-based warnings, there were a surprising number of issues that require much further research, okay? The impact-based warnings were not found to be as effective as hoped. They determined more personalized targeting and messaging towards specific activities and stakeholders would help. And by that we mean targeting of messaging. In other words, if you're, hey, I have a football game I'm going to, and I need to know specifically how that's going to be impacted. There needs to be better ways to target the information, maybe by geolocation, using your location data. If there can be a targeted way, even with AI, to send out information that specifically addresses your spot, exactly where you are, and I think that is where we're headed with all of this, which I'll discuss more about in the final week of this class too. Okay, and then I talk about how it was used globally from the Philippines, impact-based warnings, and then Asia Pacific fork areas using this quite extensively. So that's all in this content folder. So that's it for this week 3. That's it. There's a lot here, right? A lot to unwrap. But again, those are the key points here. I may add some other videos as we go along for this week. The main one I will be adding for sure will be the video that I'll be sharing, and I'll post it right here about your assignment, a few more words about the assignment and such. And I also want to mention, I'll mention this in the assignment video as well. Let me click out of this. That the reading assignments that I have for each week in the Jetstream modules. This week I'm not dealing with anything specifically. I think I referred to a chapter on synoptic meteorology, which talks about the highs and lows and fronts and all of that, just to give you a basic understanding. I'm not doing a separate video on that per se. Just read that over, just to have an understanding what you're looking at when you're looking at a weather map. And then next week, we're talking about the structure of the National Weather Service more in week 4. So looking forward, your reading assignment for next week will be a chapter from the Jetstream module webinar online school about the structure of NOAA and the National Weather Service. But the key is, those are just kind of to add some background information for your own, so you have a better foundation when you're walking out of this class of what all of this is about. But the assignment is keyed to the case study. So remember that. So look at the case study closely. Look at the assignment video I'm posting separately. It's really important you watch that. And that's all I'm going to share at this point. And again, I can't think of anything else I want to talk about. Oh, the quizzes, by the way, again, posted later in the day, Wednesday, probably toward Wednesday evening, I'll post the quiz for this week 3. And I can't think of anything else off the top of my head. So that's it for this video.